The Big Bang happens, and you've got molecules expanding from that central point. The molecules start to clump together in little clouds of nebula. The nebula, through gravity, start to really come together. As they come together, the temperature is going to increase, the density as they get closer and closer together increases, the heat increases, the temperature increases, and the rotation starts to set up within that cloud. As they pull closer and closer together, then it starts to glow. That heat from the collapse, they start to glow, and nuclear fusion starts through taking hydrogen and making it into helium. So these were the first stars. They didn't last very long, a few millions, maybe tens of millions of years. And at the end of the life of that star, then it exploded in a supernova. So the very first elements, the lightest ones from the periodic table of the elements, the first five there, they are with the smallest atomic numbers, the smallest atoms. Those were the very beginning when the Big Bang occurred. After that explosion of those first stars, the first baby stars, we started to get more and more larger molecules, so the heavier elements. Then we get all of the elements of the periodic table. Our solar system started as one of these nebulas. Move my face out of the way. Let me move it here. Oh, that's good. So we had a nebula that was a rotating disk, and that formed our sun in the middle. The hydrogen and helium left over from the Big Bang. So the hydrogens come together with the heliums in nuclear fusion, and we have all the larger atoms from the supernova now in this flattening disk. The disk had lots of matter in it, and A and B here, those are meteorites. So the meteorites, they all kind of banged into each other, and those formed what we call the planetesimals. Let me move my face again. So there's our, put it there. There's our sun in the middle, and then each of these rings were rings of planetesimals, and the planets were orbiting the sun, the planetesimals, and assimilating those bits of fragments. The Earth then formed from all those from all the planets formed from the planetesimals. They came together. They clump into what's called a protoplanet. The kinetic energy just from the bombardment and the collapse and the gravity there caused the Earth to melt. When it melted, the lighter elements rose up to the surface of the Earth, and the heavier elements, nickel and iron, sunk down to become our core. And so at this point, we had what's called differentiation, where we got different layers. So the core formed the nickel iron core, and then the silicates, the lighter minerals, rose up to form the crust of the Earth. So we have a crust and a core, and in between is the mantle that has some of the silicate components as well as some of those metals like iron and nickel. The moon, lots of hypotheses about how the moon formed, but what we've kind of settled on is about 4.5 billion years ago, one of these planetesimals or planetoids about the size of Mars smashed into the Earth. And when it did, it caused this ring of debris around the Earth. And that ring of debris eventually coalesces to form our moon. So the moon has a really similar composition to that second layer of the Earth, the mantle. So we're thinking that it knocked out that material from the Earth, and that material then coalesces to form the moon. But 4.5 billion years ago, about the age of the Earth. So the lightest elements, remember, rose up to the surface. So our atmosphere and our water is the lightest of the light elements. But most of that, the molecules of the oceans and the molecules of the atmosphere came from volcanic gases. So the Earth cools down, plate tectonics set up, uh, we have volcanic activity, and the volcanoes are letting out volcanic gases. As the atmosphere cools down, as the Earth is cooling, then that moisture is going to condense and form clouds, and we start to get weather systems, and our oceans can, not evaporate. So our oceans form, and now 71% of the Earth's surface is oceans. So just 39% hard ground. Here's a slide that kind of summarizes what I've just let me turn my face off. It summarizes what I've just gone through, starting with the Big Bang and going through the formation of the solar system, the nebula, the planetesimals in the early solar system, those rings of debris that come together to be our planets. Remember the interior of the solar system, or the rocky planets, and that lighter material formed the gaseous giants on the outside of our solar system. Okay, that's it.